Hello, in this video we will see an example on how to find the determinant of a 3 by 3 matrix. So in the previous video you should have seen how to do it just with variables, and now we will actually do it with numbers. So as you might recall, what we do first, let's make sure that it's a 3 by 3 matrix, and it is. We have 3 rows and 3 columns, so that's alright. And now, to get the determinant, we will copy the first 2 columns to the right of the matrix. So 1, 2, 4, 5, 7, 8. And now we will find the summation of the diagonals. So first let's do the positive diagonals, which are these 3, and so we multiply the elements of each diagonal and then add them to the product of the elements of the others. So 1 times 5 times 9 plus 2 times 6 times 7 plus 3 times 4 times 8, and so we get that this is 45 plus 12 times 7 is 84, plus 12 times 8 is 96. And then if we add all of them, we get that this is equal to 225. You can do it in a calculator if you don't trust me. And so it's 225 minus, and now we will subtract the diagonals that go in the opposite direction. So we will subtract the product of these 3 elements and the product of these 3 and the product of these 3 elements as well. So 3 times 5 times 7 plus 1 times 6 times 8 plus 2 times 4 times 9. And so here our first one is 105 plus 48 plus 72, and if we add them, we get that this is equal to 225. And so we subtract this to the other summation we found, to the other sum, and we find that this is actually equal to 0. So the determinant of this matrix is equal to 0, which is kind of surprising. Since we have time, we will do another example. So this one has better numbers, I hope, easier to work with. And let's make this one negative just for the fun of it. And now, so we will copy the first 2 columns. So it's 1, 0, negative 3, 1, 2, and 1. We will find the product of this, we'll find the product of these 3 diagonals, of the 3 elements of each diagonal, and then add them up. And so we have 1 times 5 is equal to 5, plus 0 and times whatever, we don't really care, it's gonna be 0 either way. Then plus 4 times negative 3 times 1 is negative 12. And so if we add all of this, we get negative 7. And so it's going to be negative 7 minus, and now that looks like an equal, but it's minus. And now we will find the sum of the products of the elements of the other diagonals. So these are our 3 diagonals right here, the ones that have 3 elements and in the opposite direction. And so it's 4 times 1 times 2, that's 8, plus, and then here we have a 0, so 0 times 1 times 1, it's going to be 0 either way. And here we have another 0, so that's 0 either way. And of course, 0 times negative 3 times 5 is equal to 0. And so if we add this up, we get 8. So we will subtract 8 from negative 7, and we get that our determinant is equal to negative 15.